Okay, thanks for the question. It is, what is the difference between atomic mass of an element and the mass number of the same element? Are they both the same thing? So the answer is no, they are not both the same thing. Atomic mass of an element is a number that you find on the periodic table, always written underneath the chemical symbol. So I'm just giving carbon as an example here, and so the periodic table will tell us that carbon on average weighs about 12.01 atomic mass units. So that is the atomic mass, or sometimes called the average atomic mass of, in this case, carbon, but that is how you find that number for generally any element in the periodic table. Mass number is a little different. Mass number is an integer, so carbon comes in a variety of isotopes. Let's just, for the sake of argument, think of carbon 12. So when I say carbon 12, I indicate that with a 12 superscript up to the left, and what that means is that there are 12 particles in the nucleus of my carbon atom. So those particles, for our purposes, are protons and neutrons. Now the thing that's interesting about carbon, or interesting about any element, is they are exactly defined by the number of protons they have in the nucleus. And that's written generally up in the top left corner, or maybe the top of every element, every entry in the periodic table. So carbon has 6 protons and always has 6 protons. And we usually give protons the symbol Z. So for carbon, we know that Z is equal to 6. If Z was equal to something different than 6, it wouldn't be carbon. So carbon has 6 protons, and we know that there are 6 protons in the nucleus. So if I've got carbon 12, what that means is that I've got 12 total particles in the nucleus, which means that I must have 6 of something else. And because I know that I can only have protons or neutrons, what that tells me is that I must have 6 neutrons in my nucleus in order to equal the mass number of 12. So that's what that number actually is. That is called the mass number. So your question, what is the mass number? That's what it is. And it is really just the tally of how many particles we have in the nucleus. So it's always going to be an integer number. It's not going to be a decimal. The atomic mass, however, will be a decimal because it is an average of all of the different isotopes that are available. So for example, we know that carbon 12 exists, but we know that carbon 13 also exists. We know that carbon 14 exists. And how you get the number that's illustrated right here on a periodic table is simply the average of the mass of all these things weighted against how frequently you find them in nature, so that if you had a sample, the average sample of carbon that you could have has a mass of about 12.01 atomic mass units, or grams per mole. So some of that carbon in your sample will be carbon 12, some of it will be carbon 13, some of it will be carbon 14. Each and every one of these has a different atomic mass, which would literally just be how massive all of its particles were if you added them all together, accounting for mass defect. And then overall, you get an average atomic mass based on how many carbon 12s are in that sample, how many carbon 13s, and how many carbon 14s. Now, every other element in the periodic table works the same way, but fundamentally, mass number is just a tally of the nuclear particles you've got, and atomic mass is the actual mass of either a particular isotope, which are known, or an average of all available naturally abundant isotopes. And that is what is indicated as the atomic mass on the periodic table. Hope that helps.